Okay, so this is a typical gas law problem. Gas laws involve three different variables: temperature, volume, and pressure. And so this question is asking, so if 75 cubic centimeters of a gas is at STP, what volume would the gas occupy if the temperature is raised to 75 degrees Celsius and the pressure is increased to 126 kilopascals? All right, so the first thing you want to do in any kind of gas law problem, or any other problem, any kind of problem that you have multivariables, is you need to organize your thoughts. And the way you do that is you figure out, okay, what variables do I have? Well, the variables you have are pressure, volume, and temperature. And so what I suggest you do is make a little table: pressure, volume, temperature, and just a simple table like this that's going to have the initial conditions and the final conditions. So the initial conditions for this, it says it's 75 cubic centimeters. So that cubic centimeters is a volume measurement. So we're going to put 75 right there, 75 cubic centimeters. And I encourage you to put the units, because what's going to happen is you may end up with more than a whole bunch of different numbers. And not knowing what those numbers correspond to without their units makes this really difficult. So 75 cubic centimeters at STP. Well, STP is standard temperature and pressure. And from table A, you know that standard temperature and pressure is 0 degrees Celsius and standard pressure is 101.3 kilopascals, or 1 atmospheres. Now, the first thing you have to recognize is what kind of pressure measurements are we using further on? Well, we're using kilopascals, so we got to keep our pressure measurements the same. So pressure is going to be measured in 101.3 kilopascals, because this final pressure is 126 kilopascals. All right. The temperature. Well, like I said, standard temperature is 0 degrees Celsius, but remember, we can't use 0 degrees Celsius. So we can't use the Celsius scale, because if you hit a zero here, you're multiplying or dividing by zeros, and that makes the number not accurate or undefined. So what we need to use is the thermodynamic temperature scale, which is the Kelvin scale. So Kelvin temperature is 273 Kelvin. That's standard temperature. Question is asking, what volume will the gas occupy? So we're going to solve for volume. So you can put your question mark here, or you can put X, or you can put whatever variable, or just leave it as V. Okay. What volume is it going to be if the temperature is raised to 75 degrees Celsius and 126 kilopascals? Well, remember, I can't put 75 degrees Celsius here because this is kelvins. So what we need to do is we need to convert Celsius, the Celsius temperature of 73 into kelvins. To do that, take your calculator and you take 75 and you add to it 273 and you get 348. So the temperature, the final temperature, is 348 kelvins. Okay, so now here's all our data. We need a formula. The formula we're going to use is the combined gas law. The combined gas law is P1 times V1 over T1 is equal to P2 times V2 over T2. What are we solving for? We're solving for this right here, which is V2. So what we need to do is we need to isolate V2. I encourage you to do it with the variables first, all right? Instead of plugging the numbers in. I know many of you want to plug numbers in and it makes you feel more comfortable. I'm going to encourage you not to do that. Instead, start with the variables. So we have two fractions separated by equal signs, so we can cross multiply and divide. All right, so I'm going to cross multiply this way, and I want V2. I want my unknown over on the left-hand side. So I'm going to take this. I'm going to say T1 times P2 times V2 is equal to T2 times P1 times V1. All I did here was cross multiply. Now I want to isolate V2. So to do that, you divide both sides by the other things, T1, P2, T1, P2. And when I do that, these factor out. Okay? And I'm left with V2, which is what I'm looking for, is equal to T2, P1, V1 over T1, P2. And now is the time I suggest you plug your numbers in. Now you want to plug your numbers. So T2, look up for T2. T2 is 348 Kelvin. This is where you include your units because you want to make sure that things are making sense. P1 is over here. This is initial conditions. This is the final conditions. So P1 is going to be 101.3 kilopascals. V1, which is the original volume, 73 cubic centimeters. Oops. Divided by T1 and P2. T1 is 273 Kelvin. P2, 126 kilopascals. And this is where you do a check. Okay, V2 is volume. The volume unit should be, right, cubic centimeters. Is that going to work out? Are you being left with cubic centimeters? Well, you let Kelvin and Kelvin factor out, kilopascals factor out, and you're going to be left with cubic centimeters as your only variable. So all you have to do now is just plug these into your calculator. Remember, when you do this, you're going to take this numerator and divide it by the product of the denominator, okay? Don't forget to do that. You can't take 348 times 101.3 times 73 divided by 273 times 126. It's not going to work that way. You got to remember order of operations. So if you're unsure of order of operations, you have to either follow the order of operations. So let's get our calculator back here. Okay. So clear all that. So I'm going to take 348 times 101.3 times 73 divided by 273 divided by 126 equals, I'm going to get 74.8 cubic centimeters is my final answer.